So this next part is using everything we've done so far in terms of differentiation and graphs, and basically combining it into such a point as we can get an equation, or vice versa. If we have an equation, we can draw the graph, and so on and so forth. Okay, so you've already looked at finding the gradient of a tangent through differentiation. However, more generally, we look to find the equation of the whole line. So this is just an extra step, basically bringing back in what we've done in National 5 in terms of finding the equation of a straight line, but using differentiation to basically find a gradient. Okay, because the same applies as when we're in National 5. If you're going to find the equation of a straight line, you need two things. You need a point, which you're generally always going to have. You might have part of it, which we'll discuss soon anyway. But the main thing with this is going to be actually finding the gradient. There's going to be nothing in the question that tells you to use differentiation to do this. Okay, so you have to establish that for yourself. But it's just, as I say, links back into what we've done in terms of differentiation already, in that when we differentiate a function, we are finding the rate of change at any point on that graph. So if we want a specific point, in other words, we want the gradient of a tangent at a specific point, all we need to do is differentiate the function and then substitute in the point at which we want to find the gradient of. Okay, so this follows much the same process, but at the end of all, we will need to use the general formula for a straight line. So you'll need to remember this. You need to remember it last year, but you absolutely need to remember it this year. We've already done straight line stuff, so this shouldn't be anything new to you. Okay, but y minus b equals mx minus a, where m is the gradient and ab is the point of contact. So as I said, we need those two things to be able to find the equation of a straight line. Okay, so the question will look something like this. Find the equation of the tangent to the curve y equals x squared minus 4x plus 7 at the point 3, 4. Okay, so nothing about differentiation in that question. Okay, all we've got is the equation of a line, equation of a curve. We've got a point, and we want to find the equation of the tangent. Okay, so going by the rules we've already looked at, if we're going to find the equation of a line, we need a point. Check, we've already got that, and we also need to find a gradient. Okay, so it's going to look like this, the curve, but you don't actually need to draw it. Okay, so this is x squared minus 4x plus 7, and at the point 3, 4, which is approximately there, we're going to have this blue line, which is our tangent. Okay, so that's what we want to find the equation of. So you don't have to draw it, but if you can kind of visualize it in your head at least, you can get some ideas as to what this equation should look like. Okay, so to get the equation of a straight line, we need two things: a gradient and a point. In this instance, we have the point of contact between the curve and the line, so therefore it is a point that lies on both, and therefore we have a and b. Okay, so this point 3, 4, it's stated in the question that is on the curve, but as it's the tangent, as it's where the tangent occurs, it is also on the line. So we have that point that we need. All we need to find is the gradient. Okay, so to find the gradient of the line, the only viable method here, so we think about previous methods we've used, we've had 2 points, okay, and used the gradient formula. We've only got 1 point here, and we're only going to know 1 point because there's only 1 point on that curve, so we can't use the gradient formula. We might have had the equation of another straight line, which we don't have. We might have had the angle that it meets the x-axis, which we don't have. So there's only one viable method here, and that's differentiation. Okay, once we've done that, we can substitute in our x value, and this will give us the gradient at that specific point. Okay, so remember, when we differentiate, the idea would be that we could find the gradient at any single point, any tangent along this curve. Okay, but we're just looking for it at one single point. Okay, so if I just pop that one over there. Okay, it helps to write this. I always do this. You don't necessarily have to do this, but these are the 3 things that we want. We want an a and a b, we want a point that's on the line, okay, and we want a gradient. Okay, so if we kind of go into the question knowing that that's what we're looking for, and then working out what we have and what we don't have, then it just gives us a basis from which to start. Okay, so we've got our a, we've got our b, we just don't have our m. We're going to find our m by taking the equation of the curve, okay, y equals x squared minus 4x plus 7, and we're going to differentiate. So dy by dx will equal 2x minus 4. Just be careful with your notation. That's y. So we'll differentiate now. We've got dy by dx. So 2 comes to the front, drop it by 1, 2x minus 4, 7 disappears. Okay. So as I say, the derivative is telling us the rate of change on this curve at any specific point. So if we substitute the x for a specific x value, we'll find the rate of change at that point. Okay, the specific x value that we want to find the rate of change at is 3. So it's just the 3 here we need. We don't need the 4. It's just the 3 that we're going to need. So when x is equal to 3, then dy by dx, in other words, the rate of change, in other words, the gradient, is going to be 2 times by 3, which is 6. Take away 4, which gives us an answer of 2. Okay, hence m equals 2. So now we can take this along with our a and our b, and we can find the equation of a line. Okay, so y minus our b is 4 equals m, which is 2, multiplied by x minus a, which is 3. Okay, and it's just a case of simplifying that as much as you can. Multiply the brackets, 2x minus 6. Add on the 4 to both sides, and you get y equals 2x minus 2. Okay, and again, it's just the same as what we had before. If you have a diagram, you can use a lot of what you've got here to just check that you're right. 2x means that the gradient is 2, means the gradient is positive. Okay, so this line is definitely positive, so that should be pretty good. And minus 2, the fact that we've got this diagram here, we can see it's going to cross the x-axis, across the y-axis below the x-axis, which means that the y-intercept would be negative. So everything that we've got there tells us that, we should be pretty good with our answer there. Okay. So in higher, you have to simplify as much as you can. Okay. It basically has to be in a form with only one constant. More importantly, it probably has to be in a form where you've only got one thing in terms of y's, one thing in terms of x's, and one thing in terms of 2's. If you wrote this as y plus 2 equals 2x, I think it would be fine. But just as a general rule, it's probably safest to just put it into the form y equals mx plus c. There's a good chance you're going to need it in a second part anyway. Okay, so you want it in the most usable form, which is y equals something x plus or minus something. So just try and put your answer into that form. Okay, so another question for you now. Okay, at P, the tangent to the curve y equals x squared minus 3x plus 4 has gradient equal to 5. Find the equation of the tangent at P. So it's the same question, we're just given something different in the first instance. Okay, so we're told the gradient this time, we're not told the point, which basically means we have to work backwards to be able to find this. So again, this is why it's perhaps useful to write down your m, your a, and your b. If we're going to find the equation of a line, that's what we want. We want a gradient, we want an a and a b value, and they're what we don't have this time. Okay, so we've got our gradient, we just don't have these values. So we're basically trying to look for a connection between what we have, the gradient, and the curve, and what we want to find. So the connection between the gradient and the curve is that if we can differentiate this, we know that there's a specific point where the gradient will equal 5. So we can take our derivative once we found it and get it equal to 5, and that will give us an equation from which we can solve to find x. And our x value will just be our a value, and once we've got that, we can find b. Okay, so again, there's nothing about differentiation in this question. It's just the connections that we have to make, or we can make from what we've got. Okay, if we have a curve and we have a gradient to a gradient of a tangent, then we know that the connection comes from the differentiation. Okay, so we're going to start with our equation of the curve. We're going to differentiate it 2x minus 3, and the idea this time is that we know that that equals 5 at a certain point. Okay, so when m equals 5, 2x minus 3 equals 5. So there's a certain point where the rate of change is equal to 5, and we want to find that point, and that's our point x. So we just need to solve this equation, add 3 to both sides, 2x equals 8, x equals 4. So that's our a value, okay? But the idea is now that we don't have our b value, but we know that there's a value where x is equal to 4 on this curve, okay? And if we can substitute it in, then we'll find out what y equals, okay? So when x equals 4, y will equal 4 squared minus 3 times 4 plus 4, which is equal to 8, and that's our full coordinate. Okay, so the tangent with gradient 5 occurs at the point 4, 8. So just working back kind of in reverse to what we did in that previous example. We still want to find the equation of the tangent, so we're still going to go one step further, and we're going to find the equation using the straight line formula. Okay, we've got everything we need now. We've got our a, b, and our m, so it's just substituting everything in, multiplying out the brackets, and then simplifying as much as we can. Right, so slightly different one this time. Okay, this involves radians, this involves trigonometry. Okay, but again, you're going to get combinations of all these different things. So find the equation of the tangent to the curve y equals 6 sine x at the point where x equals pi over 6. Again, nothing in terms of differentiation here. We've got to make the connection between what we've got and the fact that it is a differentiation question. Okay, so we've got our curve. Okay, we have our a value this time, but we don't have our m value or our b value. Okay. So I'm going to start by finding what our b value is. So we know it's on that curve. We know it's on the curve y equals 6 sine x, and we know there's a point x equals pi over 6 on that curve. So if we're going to find what y equals at that point, we just substitute our x for pi over 6. So y equals 6 sine pi over 6. This is an exact value. Sine pi over 6 is a half. Okay, change it to degrees if you want. It's 30. Sine 30 is a half. So it's 6 times by half, which is 3. So that gives us our b value. It gives us the point at which we have this tangent, pi over 6, 3. All we need to do now is find the gradient at that point. So we want to differentiate 6 sine x, which is just 6 cos x, and then substitute in our x value. Okay, so when x equals pi over 6, the rate of change, in other words, the gradient, will equal 6 cos pi over 6. So cos pi over 6 is the same as cos 30. The exact value of cos 30 is root 3 over 2. Okay, you can see this is probably going to be a non-calculator question. 6 times by root 3 over 2 is just 6 root 3 over 2, which simplifies to 3 root 3. Now we have our gradient, okay? So we had the a in the first place, we found our b earlier, we've now got our gradient, and we've got everything we need to be able to find the equation of a straight line. Don't be put off by the fact that we've got surds and we've got radians and things in here. Just go ahead as normal, okay? Y minus 3 equals 3 root 3 x minus pi over 6. And when you multiply it out, yes, it looks a bit funky, but it's nothing you haven't really dealt with before. And just simplify it down a little bit. There's a little bit in terms of fractions here, okay? So we're going to have to basically do 3 root 3 pi over 6 plus 3. I've simplified that first of all. So 3 root 3 pi over 6 becomes root 3 pi over 2. Okay, and if we're going to add on 3, then I need the 3 in terms of halves, which is going to be 6 over 2. And if I add on 6 over 2, it becomes, because it's all taken away, I can basically make it plus 6 minus root 3 pi over 2. A little bit complicated, that one. Okay, so take your time looking through that one. There's a few stages to that involving different things, but it's just your fractions from National 5.